researcher.
Hey, welcome to this week's Follow a Researcher video. Last week we discussed my research questions and we talked a little bit about the green crab problem in Maine and the spiny-headed worm that I am studying. Last week we also established that the green crab might be carrying this parasite and that its behavior might be affected by that parasite. This might make the infected crabs easier to catch, which might have an effect on the results and the data that we are collecting. This week we'll be talking about obtaining, evaluating, and communicating information, a practice that scientists use every day in their research, and I'll tell you a little bit about how I use it in my research. First, let's take a second to remind ourselves of my research questions. My first question is how many of the green crabs are carrying this spiny-headed worm in Maine, and how does that number change across different temperatures or time series? My second question is, does this number change in different variations or different types of green crabs, like red or green, male or female, etc.? And my third question is, how can we make sure that the methods that we are using to collect our data are the most accurate and the best methods that we can use? Last week, I talked a little bit about the information that we are using to ask these research questions, but where did that information come from? Typically, researchers use sources such as papers or journal articles, academic conferences, communication with other researchers, and research groups to talk about these ideas and share information amongst themselves. It's important for me as a researcher to be well-versed in all of these topics and understand all of the background information that is there if I'm going to have the most fruitful discussions and brainstorms about my study in particular. As a community of scientists, we can learn a lot about a field of study without having to be an expert in all areas. Working together to further our scientific knowledge allows us to approach complex issues by contributing our small piece to a larger puzzle. In order to know where our piece fits, it's important to understand all the other pieces that already exist in the puzzle. Specifically, in this case, my piece is this parasite and its relation to the crabs, but it's important to understand these other areas to know where that piece is going to fit and where it's going to make the most impact on this topic. So for example, information that's important to my research is understanding green crab behavior, their migration patterns, where I could find them on a beach if I were to go look for them. I also needed to know a little bit about green crab physiology, or how their bodies work, to understand what temperature environment they prefer, how salty the water can be, where we'll find them. I needed to understand a little bit more about what the common types of capture methods are. How do researchers usually try to catch these crabs? And I needed to understand all of those different fields before I was going to be able to design a study of my own. Our research team at the University of Maine has also been collecting information for the last 3 years, and we also use that information to inform our studies that we are currently working on. We've also started to establish a data set, and every year we're able to follow the next piece of information. The first year we did the study, we just established a baseline number of how many infected crabs there were in the state. Our second summer, we were able to get more in depth and look at how those numbers change among the different groups. We noticed that actually, despite its name, not all of the green crabs that we were sampling were green. Some of them were yellow or brown or even red. So we looked up some more information and we found that green crabs go through a sort of color phase life cycle. So when the crab is freshly molted, it's just grown another size and gotten out of its old shell. It's this nice bright green color, and then over time it slowly turns to yellow and brown, orange, and then eventually red. So when we went into our second summer of data collection, we decided we were going to start recording whether the crab looked like it was green or if it looked like it was red. We found that things like that actually do make a difference in the data that we're collecting. For example, we found that the crabs that looked red actually were 4 times more likely to be infected than the crabs that looked green. We saw that in females that were carrying eggs, the number went from 17% up to 50%. So that gave us a lot of interesting questions and ideas, and now we're moving into our third summer of data collection, and we're really excited to look into those. So doing scientific research isn't all about collecting information, you have to analyze that information also. Even information that we collected over the last few years, we have to constantly be looking at and critiquing and analyzing it before we know what we're going to do in the future. For example, the first summer we just were out on the beach picking up rocks and seaweed looking for crabs, and in the end we caught about 600 crabs for the whole summer. So looking at it the next summer, we kind of analyzed how we were going around and looking under rocks and stuff, and we decided that we were going to buy some cheaper tools, but stuff that could make that process easier. So we bought these large iron pry bars, and we used those to lift up bigger rocks. And the second summer that we collected some data, we went from 600 crabs up to over 3,000 using that new method. And that bigger data set gave us enough information to look at the more specific dynamics and interactions between these, the color and the male or female crabs and the different areas and all that. This year, we were fortunate enough to get some more funding available to us. So now we're looking at, are there new methods that we could be using, different types of traps that we could be using to collect our crabs? And that's what's leading us to look at whether these different types of methods are going to influence our results or not. So after we've analyzed this information and we've started to kind of prepare our findings, it's important to communicate that information with other researchers in the field. There's a lot of different ways that I've learned to do this from the other researchers that I've studied, but I will go out to conferences and I will present posters and talk to people that are coming through about our research. And I usually end up looking to them for feedback for how the project should move into the next step and what best ways we can communicate information out to the rest of the researchers in the field. So we spend a lot of time practicing our communication, the words that we use to communicate with people who might not know what we're talking about normally. And in our case, Follow a Researcher is the perfect opportunity to practice that, to go out and communicate science that's being done at a state level to students who might not even know that this research is going on. Here are some questions and topics for you to think about and discuss for this week. What topics have you learned about in your science classes recently that might apply to this green crab research? What innovative methods would you use to go catch green crabs on the beach? What other information would you like to learn about my research in general? And how do you communicate the information that you learn in your science classes? Thanks for following. You can catch a new video and see me live on Twitter each week as I answer questions from followers around the country. Where were those crabs? Aha.